Welcome to the Chemistry, Biology and Math Revision Hub. Today we're doing the Pearson Edexcel International A-Level Chemistry Unit 6 for October 2024. Let's begin with the first question. In question 1, compounds P and Q are crystalline solids. P is white and contains 1 cation and 1 anion. Q is pale violet and contains 2 cations and 1 anion. A student carried out tests to identify P and Q. Complete the table to show by name or formula the products of the tests. So the first is the aqueous silver nitrate and dilute nitric acid were added to the sample of an aqueous solution of P. This is testing for halide. And then concentrated ammonia solution was then added. A yellow precipitate was formed which was insoluble in concentrated ammonia. That means it's iodide, and the precipitate formed is silver iodide. Then a sample of solid Q was added to 5 centimeters cubed of aqueous sodium hydroxide, and the mixture was warmed. Here we're testing for ammonium cation. A pungent gas was evolved which turned damp red litmus paper blue, so that's ammonia gas, meaning this is there. And then a red-brown precipitate was formed which was insoluble in excess alkali. This should be iron 3+. So they say the gas that was evolved, it was ammonia. The precipitate was this one here. And then they say aqueous barium chloride and dilute hydrochloric acid were added to a sample of a solution of Q. Here we're trying to test for sulfate anion, and a white precipitate was formed, proving that sulfate anion is there. So the precipitate here is going to be barium sulfate. Then they say a green flame was seen when a flame test was carried out on a sample of solid P. Identify P by name or formula. P contained iodide, and because there is a green flame, that is going to be barium iodide. Then they say give the formulae of the 3 ions present in Q and hence the formula of the compound. It contains ammonium cation, iron 2+, and then SO4 2-. So how did I come about with this, the formula? You can see if it's iron, and this is the only anion, so it's going to be iron 3 sulfate, which is that, and then ammonium sulfate, which is that. So you combine, we have 2 ions, 2 ammoniums, and then we have 4 sulfates, and then get the empiric of that, which is Fe1, NH41, and then SO4 as we can see here. This is an easier way of getting the formula of the compound. Then in part B, the student added a sample of a pale brown aqueous solution of Q to a colorless aqueous solution of P. The student observed the formation of our darker brown solution along with a white precipitate. The student concluded from the formation of a darker brown solution that a redox reaction had taken place. Explain why the student came to this conclusion. This is because the iodide was oxidized to produce a brown color, which is going to be iodine. And so iron 3 in Q was reduced, showing that this is going to be a redox reaction, or a redox reaction occurred. This darker brown color is due to iodine being formed. That means iodide was oxidized as the iron was reduced. I'm talking about iron 3 was reduced. In question 2, a group of students investigated the kinetics of the reduction of peroxide disulfide ions by iodide ions in aqueous solution as shown in reaction 1. So we have reaction 1 where the peroxide disulfide is reacting with iodide to give us sulfate and iodine. And they say some of the iodine produced in reaction 1 may be removed by including a portion of sodium thiosulfate in the reaction mixture. The thiosulfate ions react with the iodine as shown in reaction 2. So this means this reaction is taking place, and some of this iodine formed is going to react with thiosulfate. So reaction 1 first and then reaction 2, or as soon as some of this is formed, it's going to react with this in order to be removed. After all the thiosulfate ions have reacted, any further iodine produced can be detected by the formation of a starch iodine complex. Student M carried out a sequence of experiments to determine the order of the reaction with respect to iodide ions. So they say the volumes of solutions used in the mixture are shown in the table. We see them here. And they say the concentrations of the solutions used were potassium iodide, potassium peroxide disulfate, and then sodium thiosulfate. We have them there. So this is the procedure. They say in step 1, a few drops of starch solution were added to 5 centimeters cubed of sodium thiosulfate solution in a small beaker. The potassium peroxide disulfate solution and water are added to the beaker. Then potassium iodide solution is added and the mixture stirred and the timer is started. The time taken to change color is recorded and the procedure is repeated for each mixture using the volumes shown in the table. So in part A, they suggest a suitable piece of apparatus for measuring the volume of potassium iodide solution. We can use a burette or the graduated pipette. These are going to be more precise. State the final color of the reaction mixture. Because we are using starch as the indicator, the color is going to be blue-black as starch and iodine interact. Then they say the reciprocal of the time taken for the mixture to change color can be used as an approximate measure of the initial rate. State why the amount of added thiosulfate ion should be much smaller than the amount of peroxide disulfate or iodide ions for this approximation to be valid. The thiosulfate added should only react with a little of the iodine. If it's in excess, then it's going to react with a lot of it, and then we cannot be able to see the color change that will enable us to see the rate. So I say it because the rate of reaction is constant at the start of the reaction, meaning it's going to be kind of a little bit slower at the start of the reaction. Then they say state why it is important that the rate of reaction 2 is much faster than that of reaction 1. This ensures that all the iodine produced initially reacts with all the thiosulfate, so that as soon as all the thiosulfate is finished, then the actual reaction with starch can start. So I say to ensure that iodine reacts with thiosulfate as soon as it's produced from reaction 1, before the produced iodine can react with starch. This accurately reflects the rate of reaction 1. Then in part B, the results that student M obtained are shown here. These are the results, corresponding concentrations, and so on. This is a complete table 2 with the iodide ion concentration in mixture 3, using the information in table 1 and the concentration of potassium iodide. So we're going to be working with this. Concentration of iodide is going to be volume of potassium iodide times the concentration of potassium iodide divided by the total. So from this table here, we're going to sum up the total volumes, we can see that, and then the concentration we have here. So here volume is 11, the concentration is 0.2, and the total volume is added here. Using the calculator, you get 0.0489, and rounding off appropriately, I got 0.049 as my answer. Then they say plot a graph of 1/time against the iodide ion concentration. So this is my graph. We have 1/time in per second, and then on the horizontal axis we have the concentration of iodide, and I drew a line of best fit but going through the origin. Put labels and units on both axes, present your points appropriately, and then you get full marks. Then they say deduce the order of the reaction with respect to iodide ions and justify your answer. It is first order because the graph of rate versus concentration of iodide is a straight line through the origin. Then they say student N carried out a sequence of experiments to find the order of reaction with respect to peroxide disulfate ions. Using solution of the same concentration, the volumes of potassium peroxide disulfate solution used were different. State the two variables that should be kept the same. This should be temperature, it could be concentration, as well as volume of potassium iodide. Others could be the total volume, volume of thiosulfate, and so on. Then student N found that the reaction is first order with respect to peroxide disulfate ions. Write the overall rate equation for the reaction of peroxide disulfate ions with iodide ions. We've already established both are going to be first order, so rate should be K into the concentration of peroxide disulfate times the concentration of iodide. First order with respect to both of them, since we have this, and for that we've already determined from the graph because it went through the origin. Then in part D, student R carried out experiments to find the activation energy of this reaction. A similar procedure was used to determine the rate of reaction at two different temperatures. The results of these experiments are shown, which we have here. And they say calculate without drawing a graph the activation energy of the reaction. You should include a sign and units in your answer. So they've given us this equation here. So using this equation, I created two equations. So if this is K2 and that is K1, this is going to be temperature 2 and that is temperature 1. I'm substituting two values at two different instances. So natural log of K2, which is that, should equal to negative EA over R times 1/temperature, which we will use this one here, and then plus the constant. So that creates the first equation, which is that, or after substituting, it's going to be this one. Then I go to another instance, natural log of K1 equals negative EA over R times 1 over T1 plus constant. And in this case, I'm going to be substituting the values in the first part. So this is going to be negative 6.03 equals negative EA over R, which we already have here, times 0.00351, which is that, plus the constant. And then this equation and that are going to be solved simultaneously by the elimination method, meaning this equation minus that equation will give me that minus that equals this minus that. So which we have here, because they have the same negative EA over R, it's going to be outside, and the rest just use a calculator. This one becomes that, and this one here becomes that. Then EA will be this divided by that, giving me 57496.21622 joule per mole, and 2 kilojoules per mole is 57.5, and it's a positive value. Others could just use it like this, natural log of K2, substitute, natural log of K1, substitute, and then in subtracting, you will actually say natural log of K2 divided by K1 equals negative EA over R into 1 divided by T2 minus 1 divided by T1. Just substitute is going to be easier instead of making it longer like this, but I was teaching, that's why I chose the longer pathway. But you could just substitute in. The K values are already known and the T's are known, or even 1 over T's are already known. Just substitute in, it's going to be easier here instead of doing it in a longer pathway. Both you get the same answer. The next I say ethane dioic acid in solution is an acidic bleach for wood. A student determined the value of X in a sample of ethane dioic acid by titration with potassium manganate 7 solution. The equation is here. The procedure is in step 1, a sample of 1.27 grams of the solid acid was dissolved in the ionized water to make 250 centimeters cubed of solution, and 25 of the ethane dioic acid solution was transferred to a conical flask. 25 dilute sulfuric acid was added and the mixture was warmed to 60 degrees. The mixture was titrated with potassium manganate 7 solution, whose concentration was that. They say describe how to make 250 centimeters cubed of a solution of ethane dioic acid in step 1. So we're going to weigh this mass of the solid ethane dioic acid using a balance. Then we'll dissolve the solid into a small amount of the ionized water in a beaker, and then we'll transfer to a 250 centimeters cubed volumetric flask, transferring the washings as well. Then we will top up to the 250 centimeters cubed mark using the ionized water, stopper, invert in order to create a solution of uniform concentration. Then explain why in step 2 the ethane dioic acid solution was measured using a 25 centimeters cubed volumetric pipette, but the dilute sulfuric acid was measured using a 25 centimeters cubed cylinder, measuring cylinder. The stoichiometric reaction, sulfuric acid is just there to acidify, but the amount of ethane dioic acid is going to affect the concentration, or it's going to affect the reaction. So I said the ethane dioic acid solution is a reactant being analyzed, so it must be measured accurately and precisely. A pipette is more precise, so sulfuric acid is only present to acidify the solution and is not part of the stoichiometric calculation, so a measuring cylinder is sufficiently accurate. Then they say state why the titration needed no indicator. This is a self-indicating reaction. Then they say suggest why in step 2 the temperature of the mixture at the start should be 60 degrees Celsius, but no further warming is needed after a small quantity of the potassium manganate solution has been added. This is because initially temperature is going to kind of boost up the reaction since the activation energy is a little bit high. But as soon as the Mn2 plus is produced, then it acts as a catalyst, auto-catalyzing the reaction. So I say the reaction between that and that is low at room temperature because of the high activation energy. Heating increases the rate of reaction once it begins because it becomes auto-catalyzed by Mn2 plus. No further heating is necessary. Then the mean titer was 19.9, determine the value of X in that. So since we were given the information for manganate, I'm going to use it to calculate the number of moles. Moles should be concentration times volume. The concentration was given on the previous page, and this is the volume here. I've converted it to decimeters cubed by multiplying times 10 power negative 3. I got that. Since the mole ratio is 2 to 5, we see moles of this are going to be in 25, which was reacted, is going to be 5/2 times these moles, giving us that. But since these are in 25, we need moles in 250, which is going to be that times 10 to give us that. Then the molar mass of ethane dioate is going to be the mass divided by number of moles. Mass was 1.27 divided by those moles, giving us that. Now this molar mass is for the whole thing, but the composition from this is going to be 90. Since this is 45 times 2, we get 90. So to get the molar mass contribution from XH2O, we will subtract this minus 90 to give us 35.75. They should be gram per mole. That is gram per mole, not grams. And then we can be able to find the composition of X, or the number of X. So this is going to be 35.75 divided by 18, giving us a 2 as the answer. Please, correction, that is gram per mole, not grams. And then in part B, ethane dioic acid dissociates into steps. The first dissociation equation is shown here. The acid dissociation constant Ka1 for this dissociation is that in mole per decimeters cubed, and the corresponding pKa1 is 1.25. Outline a practical method that would enable the student to confirm the value of the first dissociation constant. You may use the indicator data provided. Assume that equimolar solutions of ethane dioic acid and sodium hydroxide, titration apparatus, and a pH meter are available. You're not expected to include details for any calculations needed. So we see the indicator values. Since Ka equals hydrogen ion concentration when the acid and conjugate base concentrations are the same, so it means pH is going to equal to pKa. And for pKa1, it's 1.25. So I'm going to choose an indicator that changes color around that, and we can see it's thymo blue. The part in red is not necessary. I was just working at the background of my answer. So since we see the thymo blue is going to be the best indicator, I said use thymo blue, which changes between 1.2 to 2.8. You titrate ethane dioic acid with sodium hydroxide, record the volume of sodium hydroxide used by the endpoint, and then measure the pH at the equivalence point using a pH meter. In question 4, azo dyes are widely used to dye cotton fabric. The azo dye 1-phenylazo-2-naphtho can be made from phenylamine by reacting it with sodium nitrite and hydrochloric acid. The diazonium salt produced undergoes a coupling reaction with 2-naphtho. We see this one here, and then the second reaction here. There is a phenylamine used in reaction 1 is labeled with the following hazard symbols. I'll state the meaning of each. This is corrosive, this is toxic, and this is health hazard. You can see some other added parts here. Then in part B, there is a practical instructions for the preparation of 1-phenylazo-2-naphtho are shown. Phenylamine dissolved in hydrochloric acid in a beaker is placed in an ice bath. When the temperature is between 0 to 5, a cold aqueous solution of sodium nitrite is added drop by drop. A solution of 2-naphtho dissolved in aqueous sodium hydroxide in a boiling tube is placed in an ice bath. The mixture from step 3 is then added very slowly to the solution from step 2 containing the diazonium salt. The small red crystals of the product, 1-phenylazo-2-naphtho, form over several minutes. The crystals are filtered off under reduced pressure, washed and recrystallized. From ethanoic acid, another book gives the melting temperature of 1-phenylazo-2-naphtho at 131 degrees Celsius. Explain why the temperature for reaction 1 must be kept between 0 to 5. If it's below 0, the rate is going to be slower. If it's above 5, the diazonium ion is going to decompose. So I say the benzene diazonium ion is unstable above 5 and may decompose to form phenol and nitrogen gas. Below 0, the rate is going to be slow. Then draw a level diagram of the apparatus used to filter off the crystals under reduced pressure. This is the Bachner funnel, we can see that. Then we have the flask. This is the pathway to the suction pump or to the vacuum pump. We have the filter paper and then the perforations in the Bachner funnel. Outline how the melting temperature of the crystals may be measured to ensure an accurate value is obtained. Once you get the crystals, you're going to place the dry crystals in a sealed capillary tube. Ensure the crystals are at the bottom. Then you will attach that tube to a thermometer, again ensuring that the bulb of the thermometer and the bottom of the capillary tube where the crystals are aligned with each other. Then you will insert it into a melting point apparatus containing oil. You will heat slowly until the solid melts and then record the melting temperature. Then next they say, as the dyes were developed during the 19th century, but workers in the industry showed high rates of bladder cancer and the production of some dyes was discontinued. The introduction of a sulfonic acid group into the dye used for black ink for inkjet printers has significantly reduced the toxic effects. The formula for a sulfonic acid side group is shown here. We can see it's charged. This suggests how the change in solubility caused by the introduction of the sulfonic acid group reduces the toxic effects of the dye. This is ionic and therefore it's charged. It's going to make the dye more soluble, meaning it's easily washed off. So I say the sulfonic group increases solubility of the dye in water, making the dye easily washed off, and also less likely to accumulate in fatty tissues or cross-cell membranes, reducing bioaccumulation and hence toxicity. So this brings us to the end of question 4, as well as to the end of the whole paper. Thank you for being with us. Do not forget to subscribe. See you in the next video. Bye-bye.